So here in this sketch, I'll try to draw it as a real sketch, or what you can't maybe understand what this means. I'll sketch it here on the board to interpret what this means in the reality. So here we have it. I couldn't believe it when I looked at it, seeing the little short acres. And then when I got down to the camp where it does the turn, that acre was about that long. So this is the cooling equipment we have in our houses. So some part of there is return from the space, and part of the other part is coming from the fresh air. Look here, look here. Point one here, point one, number one. This is point one, coming from outside. And number two is the return air. The space air returned back to the cooling equipment. And the cooled air here is the cooled air. This is number four, point number four. This is point number four. Okay? And here is point number three, the mixing region. Here the mixing. Point number three. So we have this is a cooling coil, and this air coming from outdoor, point number one, and this air is returned from the space, point number two, and the mixing chamber, where the air mixing, let's call it the mixing chamber, three, and after the air cooled is point four. Okay, point four. So we have point one, we have point two details, we have fresh air from outdoor, dry bulb and wet bulb, and the design condition, as we speak last time, always design condition is 75 degree Fahrenheit and 50% relative humidity. Okay, so we have two parameters here. We have two parameters here. We can't find them on the psychrometric chart. Only this is missing, unknown. We'll use this equation, the equation T3 equals A T1 plus B T2, and A and B is the percentage of the flow rate of the air. So suppose A equal 0.25 and B equal to 0.27. B is the percentage of the return air, and A is the percentage of the fresh air. And when we apply this equation, we can find T3. Okay, T3. So we go to the psychrometric chart.
Wait,
And
isn't one of those 75? Or it's both 0.25? No, I thought one.
no, this is 75 degree Fahrenheit.
Right.
And this is, I'm sorry, the percentage is 75,
Right.
yes. Because this is 25, so the
Right,
remaining is
right.
75 of the,
Just
okay.
check.
So we go to the psychometric chart. What we will do? We find first point 1. We have a dry bulb and wet bulb here. We have a dry bulb and wet bulb temperature. Here we have the dry bulb temperature and we have the relative humidity. So intersect for the indoor condition. The indoor condition, we have the dry bulb temperature, which is, as I told you, it's standard. It's not changed.
Right.
75
50%.
and 50%. So we find this and find this. We find this fresh air here, and we find the indoor condition here. And we use a ruler and draw a straight line between them. So this is 1 and this 2. Okay? We find 1, we find 2, then we need to find the 3. A 3, we use this equation to find T3 dry bulb temperature. Okay? Okay. So suppose we found it something like 80 or 85, for example. 85. We go to the horizontal axis, which represent dry bulb temperature, and we find the 85 degree Fahrenheit. And from this point, we draw a vertical line. And when this vertical line intersects with our process line, so this is the point number 3. Okay, point number 3.
Okay, say that again. Okay, so when you come to the third conclusion, right, with the third temperature, which is 85, you just draw a line all the way up, and as soon as it intersects,
Yes,
that's the second
vertical line.
vertical line.
Yes,
That's
you have vertical line on the psychometric chart.
right.
You have vertical line, which is the constant dry bulb temperature. So put your roller parallel, or you'll find maybe 85 a constant dry bulb temperature already drawn on the psychometric chart. Just follow it,
Just follow
and when it's intersect with this line, we find point 3.
Okay.
Okay. Now, point 4 already also we have 2 parameters, 60 dry bulb and 55 wet bulb. So we look for 60 dry bulb and wet, and 55 wet. We find it maybe here, somewhere here. Okay, we found this is point 4. Now, we draw a line from point 3 to point 4. This new line, what does a new line represent? This new line represents the process of cooling the air when it's passed through the cooling coil. Okay, so you remember you remember when we draw the cooling and dehumidification. You remember this is cooling and dehumidification.
Right.
This is process of cooling and dehumidification, and then we have the enthalpy scale. Okay, and we draw a line parallel to the constant enthalpy and drop it on the scale for 0.4 and 0.3. Okay, we'll find H3 and H4. So H3 minus H4 will be the result will be in BTU per pound. What's that mean? Every pound passed through this coil will lose this amount of heat content. That means the load on the coil for each pound is this amount. Okay, this amount of heat will be lost or absorbed by this coil for each pound. We get this amount of heat. What's that mean? Now if we have the flow rate of the fan, say we have an example. Let's return back to you. Remember the equation for? You remember this equation? Q total. Equal 4.5 multiplied by CFM multiplied by delta H. This is delta H. This is delta H. H3 minus H4. So if we have the capacity of the fan in CFM, what we'll get? We'll get the total. We'll get the total load on the Coley coil. What's that mean? We find the capacity. Actually, we found the capacity of the coil. Then we can convert in BTU. We can convert it to ton. You know, every 1 ton refrigeration ton equal to 12,000 BTU per hour. So we'll find in BTU. We divide it by this. We'll find the capacity in the refrigeration ton. You hear this equipment is 2 ton, 3 ton, 4 ton. They find it like in this procedure. Understand it?
Yeah.
Okay. We'll do it step by step. Okay. Let's go ahead and find point 1. So you have every data needed on the screen. Every data needed on the screen, and go ahead and find point 1. Okay.